This is a temporary video I'm putting together here just to show a 512 by 342 image being displayed natively on a 4.5-inch black and white CRT. The CRT in question is an old television that uses the AN5151N video all-in-one chip. Pretty common for TVs of the age between mid 80s and early 90s. Also, some later cheap $20 pricing or so CRTs also had this chip, as well as much larger TVs. The chip was not specifically designed for small TVs. You can see that I've pulled up here the video output chip and the audio output chip. The audio output pin is actually unnecessary, strangely enough, on this monitor because the tuner seems to route the audio signal directly to this to the audio subsystem rather than utilizing the audio output from the actual all-in-one chip. I've also removed, as you can see, anything regarding the main components regarding the tuner, the actual pots therein, and so forth. Anyway, I've used a test point here for the video input signal, and another test point here for the ground signal. This all is running through really bad jumper wires over to a Raspberry Pi 4 using a VGA shield that I've had sitting around for ages. The VGA shield is based on Gert's VGA 666 project and is relatively well supported on Raspberry Pis in general. However, I am told that because of the custom timings I'm using for the pixel clock, what I'm doing probably will not work on anything before a Raspberry Pi 4, which honestly isn't really a big concern considering I wanted to use a Raspberry Pi 4 for this project anyway, given its higher performance and ability to emulate things above a classic Macintosh. In the absence of a proper sync combination circuit, I've used a very poor man's solution of tossing in effectively 860 ohms, 680 ohms resistors, 680 ohm resistor total between these two resistors, connected to what I thought was combined sync, the H-sync plus V-sync on one pin. However, it looks like that this shield only outputs separate sync, and thereby resulting in the rolling image that you'll see shortly here. I've taken the actual monitor and adjusted the vertical sync as well as all the other settings internally to get the image stable on the screen. However, because of the vertical sync issue, the image still scrolls, and vertical hold is the only thing that's preventing it from rolling forever and ever really fast. So pretty standard compensation, but you'll see that the image doesn't stay stable for very long, and when it does stay stable, it doesn't actually line up with any synchronization. Okay, so without further ado, we'll turn on the TV here. Wait for it to warm up a little. You can see the flyback lines as well, which not much I can do about that at the moment until I throw some pull downs on the actual video signal. That's the actual all-in-one chip isn't helping matters much here, but on the upside, at least we have proof that the video raster is being built correctly. So once we power it up, that will go away once there's actually image being drawn on the screen and the guns aren't trying to overdrive it. So here we go. You'll see the image cleaned up right away. It still pops up here and there. So we're booting the Raspberry Pi. We've got our Pi logo coming up here, and let's go back to boot prompt. You'll see that the screen is scrolling, but is very clear. Looks wonderful after I was able to get a progressive scan 512 by 342 image on this. Technically, other resolutions are definitely capable as well. It just there's a limit to exactly what kind of resolution you can shove through a TV like this. The flyback, I'm almost at the limit of how much voltage I can feed the flyback, at least with the built-in with the built-in circuit that's already built in. So anyway, log in here. You'll see shortly that the image becomes a little more stable. Depending on what's shown, sometimes the monitor is a little more or less stable. So I'm going to launch terminal here. You can already see some distortion here at the top of the image. I've tried adjusting the size of the front porch and sync signal, and have had a little improvement on that. However, I think we're also dealing with old capacitors and other issues as well. There's also squash issues, all sorts of fun geometry problems that tuning the monitor and or replacing a lot of the components and everything required there. The main goal here is that a dedicated circuit will be made to drive the CRT and remove all non-essential chunks as well. So anyway, here we'll fire up a screenshot to show, let's see here, I think I still have it in, there we go. So this is a screenshot running at native resolution, 1:1 resolution of a, coming off some Mac Plus or something like this, random screenshot I just pulled online. You'll notice there is distortion on the menu bar. It's not horrible, but it is definitely a concern, and it's completely based around issues with the CRT as itself. Usually this falls into the overscan. Because I'm using the full size of the raster, it shows up on the main image and no longer, you know, is definitely of something that needs to be compensated for. Presumably fixing some of the capacitors should help this, but it's still up in the air, and realistically, tuning the sync size and front porch, back porch might help that as well. You also notice that while, sorry, let's get this focused in. You'll notice that while the on-screen, anything on screen looks pretty crisp overall, there's also some bleed over. You can see this very distinctly right here. You know, when you have one line ending into another, different things like that, and that propagates even further when we start looking at the raster for, or the moire pattern here for the background, which is supposed to be a standard checkerboard. Overall, I think it is very usable already as it is, if I can get the sync issue straightened up and try to fix some of the geometry. But definitely could do better.